Hello everyone, myself Sridhara MK, working as an assistant professor, Government Engineering College, Bangalore. I welcome you all for this lecture series on municipal wastewater engineering, subjected to 5th semester in civil engineering. This video we are presenting as a part of our learning management scheme under the Department of Collegiate and Technical Education. In our earlier semester, we have discussed about the importance of the water supply system. In this semester, we are discussing about the sanitation facilities, and we are going to make for the different regions like villages, towns, and cities. In first lecture, that is in session 1, we have discussed about the introduction part of it, and in this session 2 we are going to deal about the content of dry weather flow, wet weather flow, time of concentration, and some model questions. What is meant by dry weather flow? Dry weather flow refers to a flow in a sewer system during the periods of minimum infiltration. That means to say, in the dry condition, the flow of sewage that takes place in a residential, industrial, and commercial areas. What are the factors which are going to play a role in the quantity of dry weather flow? The important 4 factors what we have considered here are the rate of water supply, population growth, type of area that is going to be served, and the last one is infiltration. As the first we take rate of water supply. The rate of water supply to a city or a town usually expressed in liters per capita per day. The quantity of sewage is produced always less than the rate of water that has been supplied, because as mentioned, due to some consumption like drinking, cooking and bathing and other purposes, residential purposes, some quantity will be get utilized. Therefore, always there will be a reduction in the sewage due to some of the domestic uses that have been listed. I think the consumption, evaporation, usually lawn sprinkling. Whenever firefighting occurs, we have to adopt these firefighting arrangements so that some quantity will be get utilized in the firefighting, and also in the industrial consumption. Some of the industries are going to have the water supply facilities, so there will be a consumption for the industrial purpose also. By considering all this, while designing our sewerage system, we have to design the sewers, means finding the diameter of the sewers by taking the minimum rate of water supply as 150 LPCD. Coming back to the second factor, population growth. Mainly the quantity of sewage produced very much depend on the population in the area that is going to be, I think we are going to provide the facility. Finding the quantity of sewage, we know very well that the population in that area by multiplied by the rate of water supply what we are going to supply, we can able to find the quantity of sewage. And also we are going to design our sewer by considering a design period for which we are going to design our sanitary system. Second one, type of the area that is going to be served. As earlier we discussed, we are going to serve rate of water supply for different areas. Those areas may be of residential, industrial or commercial. Again, quantity of sewage produced depends on the nature and size of industries. Last one, infiltration and exfiltration. This factor play an important role in the quantity of sewage, in fact dry weather flow. Usually subsoil water enter into the sewer pipeline because sewer lines are laid below the ground through the loose joints. This is an infiltration. Whereas exfiltration is a reverse process, that is flow from sewer pipeline into the surrounding soil mass. So sewage is going to enter into the surrounding soil mass. Usually infiltration leads to increase in the quantity of sewage, whereas exfiltration results in decrease in the quantity of sewage and consequent increase in the pollution of the groundwater. And also infiltration leads to unnecessarily increase the load on treatment plant. Next topic, wet weather flow. That is flow that is taking place during rainy season. Usually used to called as storm water flow and is also called as wet weather flow. Some portion of the rain usually infiltrates into the ground. Remaining will flow on the ground surface as a runoff, including flow on different surfaces like pavements, house roofs, and other areas, etc. There are some factors which are going to affect storm water. They are listed below. They are of rainfall intensity and duration, and area of the catchment where rainfall is going to fall, and slope and shape of the catchment. This is very important. Nature of the soil and degree of porosity like sandy soil and hard soil, and initial status of the catchment, whether it may be dry or wet. You have a two schematic, pictures you can able to visualize. In the left hand side you have a vegetation and right hand side you have an urban area. So in the left hand side, due to the vegetation, the infiltration is more when compared to the urban area, where urban area is going to be paved. In the vegetated area, there will be a shallow infiltration and deep infiltration. It will add it to the natural ground cover. Whereas in the impermeable layer in the cities, we have a less amount of shallow infiltration and deep infiltration. That's why runoff will be more in the urban areas, surface runoff, whereas surface runoff will be less in the vegetated area. Regarding the next topic, estimation of quantity of storm water. Usually there are two methods. First one will be the rational method and second will be the empirical formula method, which are going to use for finding the quantity of storm water. Rational method, as we find the storm water discharge, you have a formula Q is equal to CIA divided by 360, where Q is equal to quantity of storm water. It is measured in the units meter cube per second, where C is equal to coefficient of runoff depending upon the characteristics of the catchment. I is equal to intensity of rainfall, where A is equal to area of drainage, that is in hectares. Coming to the finding of the coefficient of runoff. Runoff coefficient depends, I told, mainly on the characteristics of the ground, such as porosity, wetness, ground cover, etc. Runoff coefficient varies from 0.01 for forest and wooded area, whereas 0.95 for watertight surfaces. So where 0.01 is there, infiltration rate is high, where 0.05 they are impermeable in nature, so infiltration is absolutely less, therefore runoff will be more. Depending upon this, we are going to find out the runoff coefficient as a whole with respect to different areas and different characteristics of the catchment. So with a simple formula, that is A1C1 plus A2C2 plus A3C3 plus ANCN divided by A1 plus A2 plus A3 plus so on AN. where A1, A2, A3 are different types of areas, and C1, C2, C3 are their runoff coefficient respectively. By this time, the table showing the different runoff coefficients for various surfaces, we are going to consider making some studies. We have, I think, find out some of the coefficients with respect to different surfaces. They are have a list, usually watertight roofs. Watertight roofs in urban areas, asphalted cement surfaces maybe around 0.85 to zero point 0.9. Portland cement streets around 0.8 to 0.95. Paved driveways and walks 0.75 to 0.85, and gravel driveways and walks 0.15 to zero point 0.3. Similarly, residential areas, single family areas, 0.3 by 0.5, whereas this here impermeability is less, and multi units 0.4 by 0.6. Again, depending upon the soil and slope. Sandy soil 2% slope. Look at here, the coefficient is 0.025 to 0.1, whereas for 2 to 7% slope, that is 0.1 to 0.15. Depending upon the heavy soil, that is 2% slope, the impermeability factor increases by 0.13 to 0.17 because infiltration rate is less and coefficient becomes more. Depending upon 2 to 7% slope, that is around 0.18 to 0.22. More than 7% slope, it is 0.25 to 0.35. Again, second method, empirical formula method. Usually empirical formulas are applicable only under certain specific conditions such as slope of land, imperviousness, and rate of rainfall. By considering all these three factors, they have developed formulas by different, I think, authors. That is McMurch's formula, Q is equal to CAA divided by 148.35 root of 5 S by A. Burke and Ziegler's formula, Q is equal to CAA 141.58 fourth root of S by A. Fuller's formula, Q is equal to Cm to the power of 0.8 divided by 13.23. Talbot's formula, Q is equal to 22.4 m to the power of 1 by 4. Fanning's formula, Q is equal to 12.8 m to the power of 5 by 8. In all these area, A is equal to area of drainage in hectares, whereas M is equal to area of drainage measured in terms of square kilometers under different formulas. Remaining four, that is Q, C, I and S will be same for all. Runoff will be in metric cube per second, and C is the coefficient of runoff. I is intensity of rainfall, is measured in centimeters per hour. S is equal to slope of area in meter per 1000 meter. In order to find out the intensity of rainfall, the empirical formula developed by British Ministry of Health is given by I is equal to 760 by T plus 10, where I is equal to intensity of rainfall measured in millimeters per hour, where T is equal to duration of the storm. The first equation, I is equal to 760 by T plus 10, where for small storm durations, that is around 5 to 20 minutes. The second formula regarding intensity of rainfall for storm duration, that is of 20 to 100 minutes. Usually T is measured in minutes, whereas intensity is expressed in millimeters per hour. Coming to the topic, time of concentration. The time of concentration shows the reaching time of the water once precipitation starts. Flow takes place. Means the total time taken for the maximum runoff to takes place. Time of concentration is made up into two parts. One is inlet time and another will be the channel flow time. Mathematical expression Tc is equal to Te plus Tf, where Tc is equal to time of concentration, T is equal to time of entry into the inlet, and Tf is equal to time of flow in the seaway. By knowing all these concepts about dry weather flow, wet weather flow, and finding the quantity of the storm water and also the time of concentration, how the water is going to enter into a sewer line. By knowing all these factors, in order to know the, I think, relevant difference and importance of all these topics, we will go on these multiple choice questions. First one will be in the design of the sewers, the time of concentration is relevant to determine. Options are rainfall intensity, velocity in the sewer, time of travel, area served by the sewer. As time of concentration, always it deals with the rainfall intensity. So how much time the rainfall has been taken place. That's why the option A is rainfall intensity. Coming to the second question, for the design of a storm sewer in a drainage area, if the time of concentration is 20 minutes, then the duration of rainfall, usually the time of concentration and duration of rainfall almost same. Therefore, in this contest, we have an options A is 10 minutes, B is 20 minutes, C is 30 minutes, and D is 40 minutes. So, answer is choice B, that is 20. Coming to the third MCQ, dash is the flow through sewers available during non-rainfall period. Means absence of rainfall. Whatever the water that has been supplied that is converted into sewage in the different residential, commercial and industrial areas. So the sewage produced in the dry condition, the answer is C, that is dry weather flow, irrespective of other choices A, B and D. Coming to the fourth multiple choice question, dash is the additional flow occurring during rainy season. The options are gradually varied flow, rapidly varied flow, dry weather flow, storm water flow. As we know, additional flow during rainy season, additional flow is due to the precipitation. Whatever the runoff that is going to flow over the ground surface will be reached as a storm water flow to the sewers. So our option is for D. Fifth question, the quantity of wastewater is assumed to be dash percent of the quantity of water. Very important question. As we know, whatever the water that has been supplied, the after the consumption and using for various uses, the after usage, water will be converted into wastewater. Some consumption has been taken place regarding drinking and evaporation, other things. That's why usually 80% in the choice of A 40, B 50, C 60, D 80, 80% of the water that has been supplied will be converted into the wastewater. Therefore, option D is 80. Coming to the sixth question, the sewer should be designed for a minimum of dash liters of wastewater per capita per day. As we know, so usually while designing the sewer line, we have to consider the population and rate of water supply into consideration. So by that time, we know population from the census records, but rate of water supply minimum we have to take, that is option C, that is 150 liters for the design of the sewer. Coming to the seventh question, the size of the town is 15,000, means population is around 57. What is the density of population per hectare? So options are A 50, B 75, C 100, D 200. The option is D 200, that is 200 population per hectare. Coming to the eighth question, dash is the process which indicates the flow of wastewater from the sewer into the ground. That is exfiltration, infiltration, filtration, osmosis. So the A, first one, that is exfiltration. Coming to the last MCQ, the wet weather flow is also known by options: minimum sewage flow, maximum sewage flow, storm water flow, average rate of flow. As we know, wet weather flow is also termed as storm water flow. The option C, that is storm water. So by this time, end of this session. Thank you.